All right, friends and neighbors, it's time for SSH parts and, oh yes, packets. To begin, there are two versions of Secure Shell. You always want to use Secure Shell version 2 because that's the one that has the security improvements, including Diffie-Hellman. Secure Shell, unlike Telnet, uses TCP port 22. And we can learn about the overall SSH architecture with RFC 4251. A lot of the description is in there. And if you'll read along with me, the Secure Shell protocol is a protocol for secure remote login and other secure network services over an insecure network. This document describes the architecture of the SSH protocol, as well as the notation and terminology used in SSH protocol documents. That means there's more of them. It also discusses the SSH algorithm naming system that allows local extensions, so modifications to the SSH protocol. Now, there are several parts to the SSH architecture. Some are used more than others. So when you do an implementation, not all of these parts are heavily utilized, but here we go. So there's probably the big one is 4253, the transport protocol. So that's server authentication, confidentiality, and integrity with perfect forward secrecy. Now, I've also included what are called the message numbers. Now, if you've been on this channel at all, you know that when we look at protocols, messages almost always have a type associated with them, right? Now, Wireshark or something like that will tell you what it is. This is a link state update, you know, or something like a router update or something like that. And SSH is no different. So each one of these protocols has its own series of messages, and so I just included those here. Then we've got RFC 4252, the user authentication protocol, which authenticates the client to the server. And that sort of makes sense, right? You're going to log in at some point. And 4254 is the connection protocol. And that's where you might have several connections over the same logical channel. And there's its numbers too. So the basic idea goes like this. When you have nodes that wish to communicate via SSH, you've got to generate keys. And then you got to have some way to spread the keys around, or at least spread the public key around. So what happens is, on the server, you generate keys, and you wait for clients to connect. So on the client, you're going to say, I want to use SSH. So for example, in PuTTY, you'll pick an SSH connection, and then put in an IP address, or a URL that you're going to, and then you connect to the server. And the first time you connect, pow-pow! There's this big window that pops up. Do you want this host key, right? So it says here in the security alert, the server's host key is not cached in the registry. What this is doing is sending you the certificate for the server. The certificate includes the server's public key that clearly this host did not have in its registry at this time. Now, importantly, after you accept this, the next time you connect to that server, you won't have to do that. Why? Because when you can connect to that server and the currently stored public key works, you've really just authenticated the server. If you went to any other server, what would happen? You get one of these windows, or your connection would fail because the public and private keys wouldn't work together. So that's an important aspect. The very fact that you have the public key and can connect to that server sort of verifies the identity of that server. Okay, so now the user is authenticated and the connection becomes encrypted with a session key. So according to the RFC, right, the session key and the encryption algorithm are negotiated during key exchange. We'll see that here in a second. And then we consider the two data streams, that is from the server to the client and the client to server, as two separate animals. And everything about them can be negotiated separately. So here is an example of the initial exchange, right? We've got a key exchange, and I've also highlighted that it is packet number 20, or the type is 20. And so that falls into that category of messages. And we can see that we're doing a key exchange init. So this is actually the very beginning of the connection, and they're trying to decide what algorithms they're going to use. And I've just sort of highlighted in the box here all of the different algorithms that are possible. There's a squillion algorithms. So another important thing to realize is that there's a difference between having keys or keying material, and then the algorithm that you're going to use to munge up all the data so nobody can read it. So those are two different animals. And a lot of times we can encrypt data with one algorithm and we can encrypt the transmission with another one. So we have to keep these ideas separate in our minds. And then I'll just point out that above this, we can also see that there's an HMAC SHA-1. That is a hashed message authentication code, which is a number that's appended to the end of this message to verify a valid message. So that's the message authentication code that we see used with these kinds of things as well. So here is the packet exchange. This is the entirety of it, right? So this is probably an SSH connection that is not utilizing all of the possible options that we can see. We can see that initially we have the user connected, and I'll just point out that the IP address that I used here in this case is 1.1.1.1. We'll see where that comes from here in a second, and then I was connecting to one of my network devices. So the username and password are exchanged, and then there's a key exchange, and then what they're doing is they're picking the algorithm that they're going to use, and they're figuring out what the session key information is going to be. And then we can see the new keys have been distributed, or the new keys have been chosen, and then the packets are now encrypted. At that point, right, you have the IP header, which you can see and read clearly, the TCP header, which you can see and read clearly, the SSH header, which you can see and read, and then all of a sudden it's encrypted. It's garbled data, so you can't read above that. So this is what we call encrypting above layer 4, or application layer encryption. So here is part of the configuration for this particular connection, right? And the key for this is that, again, there was the username and password, same thing. The IP address, 1.1.1.1, I was using a loopback address. And I just put that in there because for those of you wishing to do some advanced networking, loopbacks and management interfaces are important to us. So those, you got to make those part of your toolbox. And then, of course, now on the VTY connection, instead of Telnet, it now says SSH there. Now, another note that I've made here on SSH port forwarding, a lot of times we have an intermediary working for us. In that case, you're going to send data to a device, and then it will forward to the destination. The other part of SSH is that sometimes we can't always get to the box that we need to. And so you're going to connect to the server or the NAT box, and then have it forwarded to the right destination. So we call that redirection or port forwarding. So there we have it, SSH for the win. It's not actually all that difficult to implement. You generate the keys, create the user accounts, indicate that the transport that you're going to allow to this particular device is only SSH. You might even do things like allowed IP addresses and stuff like that. Then you're going to tell the client to connect via SSH. And then you've got to accept those certificates, right? You got to get those certificates around, and then you're just heading for the finish line with a secure connection. Now, go forth and be secure. Thanks for watching. Thanks for listening to this discussion about SSH. I hope it helps. May your packets always reach their destination securely.